Hey everyone, so for this digital SAT math prep course, you're going to be able to access 50 plus practice questions and solutions. And these questions are going to serve as essentially another practice test if you work through them, because there's a mix of easy, medium, and hard questions. Now the percentage of these questions, the way they're distributed, is weighted based on the content domain. And these domains are provided by College Board, and so it's up to date and accurate. And all these questions are actually vetted and straight from the College Board question bank. Now we already have a digital SAT English prep course that goes over concepts, grammar, writing, everything you need to know. Make sure you check that out as well after this video, and good luck on your exam. The question says the cost of renting a backhoe for up to 10 days is $270 for the first day. And then it is an additional $135 for each additional day after that. Up to 10 days. So which of the following equations gives the cost y in dollars of renting the backhoe for x days, where x is a positive integer that is less than 10, but it can be equal to 10. All right, so let's look at our options here, and the first one I want to cross out is C, because C seems like the obvious answer, because you start off with $270 on the first day, and then it costs $135 for each additional day. So you might think that it's 135x as a slope, which it is, but there's something else you have to consider. So if you think about it, y is the cost in dollars. And we know because it tells us it's $135 for each additional day. So each day is going to cost $135. And it says the renting the backhoe for x days, so x is represented by the number x. So it's 135x. But now we need to find the y-intercept. And we already said the y-intercept is not $270. And to help you visualize this, let's say x was 10, right? So it'd be 10 days. So what we get is 10 times, it's kind of hard, right? 10 times 135, right? So this would give us 1,350. All right. So that's a very large number. However, it's missing one thing, because we know here it says it costs $270 for the first day. So if you think about it, if it's $270 for the first day, when we accounted for the 10 in our rule, we only paid $135. So in reality, we only paid $135 of our intended 270. So we can do 270 minus 135, and that gets us 135. And so we know that this is the unpaid amount, and so we need to add this to the end of our rule. So it's 135x plus 135. And so our answer is choice D. Culture of bacteria is growing at an exponential rate as shown in the table above. At this rate, on which day would the number of bacteria per millimeter reach 5.1 times 10 to the power of 8? All right, so the first thing I want to do is just find the factor or the scale. It's known as the common ratio, and since it is a x growing at an exponential rate, we know it's a geometric sequence. So from 2.5 times 10 to the power of 5 to 5.0 times 10 to the power of 5, that's going to be a scale factor of 2. And because it's increasing at an exponential rate, it's going to be the same rate between each value. So this is also 2x. All right, so now let's write our rule out. So we're going to write f of n, because we're going to write a function rule where n represents the number of days. We start off with our first term, because that's just what is being affected at the start. So 2.5 times 10 to the power of 5. And now we want to multiply this by our common ratio, which is more commonly known as just our scale in between each one. So bring this down so you get 2. And now this has to be raised to the power of n, the number of days, right? But something you'll find is we can't just leave it like that, because if n equals 1, we're going to get 2 to the power of 1. And 2 times 2.5 times 10 to the power of 5 is not the same thing as 2.5 times 10 to the power of 5. That would instead give us the value for day 2. Therefore, we need to write a minus 1. And the reason for this is because n we called n starting at 1. Whereas if n was 0, then it would work out. So we have to include that -1, very important, in order for this function rule to work. And if you want, you can just plug in day 1, day 2, day 3 into this equation. You'll see it works out. So now in order to find the day that it would reach this 5.12 times 10 to the power of 8, very simple here. We can just use our calculator, but to do so, we need to set up our little equation. So it's just this equation. 2.5 times 10 to the power of 5 times 2 to the power of n minus 1. And this is going to be equivalent to 5.12 times 10 to the power of 8. And in this equation, we're just going to solve for n. And I'll do the heavy lifting here with the trusty calculator. And that is going to give us a value of 12. So we know that the final answer is day 12, choice D. This one says, in the given equation, b is a positive integer. The equation has no real solution. What is the greatest possible value of b? So they give us a quadratic equation, negative x squared plus bx minus 676 equals 0. So in order for us to solve this problem, we need to calculate what is called the discriminant. So the discriminant is what you're going to find in that quadratic formula. So that is square root of b squared minus 4ac. All right, so if you didn't know, the discriminant determines the number of solutions a function has, or a quadratic function has. So if this value is positive, that means it has 2 solutions. If it is negative, then that means it has 0 solutions. And if it's equivalent to 0, that means it has 1 real solution. So in order for us to calculate this, we just need to know what the this part right here, the negative 4 times a times c, is equivalent to, and then just find a b value that is less than that, but the greatest possible value. I'll show you how to do that. So let's first calculate negative 4 times a, we know our a value is negative 1, times c, our c value is negative 676. And this will give us a value of negative 2,704. All right. So as we talked about before, we need to know that the value of b squared has to be less than 2,704, but it has to be the greatest possible value. So what we can do is just set b squared equivalent to 2,704. Not negative 2,704, because this has to be a positive value in order to be subtracted, right? And so now we're just going to solve for b. So if we take the square root of both sides, we're going to get b is equivalent to the square root of 2,704, which is oddly equivalent to an odd number, whole number, which is equivalent to 52. Now 52 is not our final answer, because if b is equivalent to 52, our discriminant would be equal to 0, and we would have 1 solution. But this equation has no real solution. And so we know that b is a positive integer. So in order for b to be a positive integer, it is just the number that is below 52. So the next closest value under 52 would be 51. And so the greatest possible value for b is 51, because if we can test this, 51 squared is 2,601. And that is indeed smaller than 2,704. And so if you did the math there, you would get a negative value. And so the discriminant would have a negative value, meaning you would get no solution. And that would ultimately solve the problem. The expression 3 times 2x squared plus px plus 8 minus 16x times p plus 4. P is a constant. This expression is equivalent to the expression 6x squared minus 455x plus 24. What is the value of p? So here we have 2 missing variables in this one equation. So that is going to make it a little bit tricky to solve. But the thing to notice here is that p is only in the values of x. So what I mean by that is you can see 3 times px, right? That's going to give you 3px. And then over here you have negative 16x times p. That's negative 16px, right? So that is all under the same x term. If we look over here, that means it's only going to affect this term right here, negative 155x, because p can be anything and it won't affect the 6x squared or the plus 24 constant. All right, so let's set up our equivalent equation, because it says this expression is equivalent to the expression. Therefore, we can set up that equation, isolate for p, and we'll be good to go. So 3 times px is just 3p. And I'm going to negate the x's for each of them because x is in each of these equations and it's just a substitute variable. So we can just negate that. Over here we have negative 16x times p. So just negative 16p. And I almost forgot the plus 4. So p plus 4. And that is all equivalent to, we're negating the x, so that's just negative 155. All right, let's just do some distributive property. So negative 16 times p, negative 16p. Oopsies, okay. All right, negative 16 times positive 4 is just negative 64. And then we have 3p on this side. And this is equivalent to negative 155. And let's just do some simple algebra, right? We add 64 on both sides. And that will give us 91 on this side. And so now we're left with 3p minus 16p on the left side. And that will give us negative 13p. Alright? And we can divide by negative 13. Boom. Boom. Oh, I actually made a mistake here. It's negative 91. That makes sense because a negative over a negative. So negative 91 divided by negative 13 gives us p is equivalent to 7. Alright? So our answer choice is B. The line with the equation 4/5 x plus 1/3 y equals 1 is graphed in the xy plane. What is the x-coordinate of the x-intercept of the line? So we're looking for the x-coordinate of the x-intercept of the line. All right, so the x-intercept. The x-intercept is where, let's say you graphed. I'm just going to write a random equation. So let's just say we have like a quadratic formula, right? So these, where it hits the x-axis, would be the x-intercepts, right? The zeros. And so at these points, if you were to write out the coordinates, you would have 0 as your y value, right? Because whatever x value you have, it outputs a y value of 0. And so in our case, we know that the y value in this equation, it has to be 0 if we're representing it to find the x-coordinate of the x-intercept. So then we have 4/5 x plus 1/3 times 0 is 0. So plus 0 equals 1. And now we can just solve for x, because if we solve for x, because y was 0, then that means we're solving for the input that gets us 0 as y. And this is a function. So what is x? Well, what do we multiply 4/5 by to get 1? Well, we can multiply 4/5 by 5/4, right? Because this gets us 20 on top and 20 on the bottom, and that is equivalent to 1. And therefore, the x-coordinate of the x-intercept would just be 5/5. So that is our answer. Figure AC equals CD, okay? And the measure of angle EBC is 45 degrees, so let's label that. Boom. Okay, and the measure of angle ACD is 104 degrees. What is the value of x in degrees? So the value of angle AEB, that's what we're trying to find. So the angle of AEB. Okay, so how I like to approach, just geometry problems in general when you're trying to find an angle is just, don't try and take it in all at once. Just take it step by step, break it down, see what angles you can find, see what theorems you can implement, and eventually, you never know, you might find the answer from that. So first off, they tell us that AC equals CD. So this triangle right here, triangle ADC, this is a isosceles triangle, right? Because these two side lengths are equal, then we know that these angles here, angle D and angle A, are going to be equal to each other. because there's only 180 degrees in a triangle, and we know angles ACD is 104. I should add units. Boom, boom. So that gives us 76 degrees between those two angles. And so we can divide that in half, and we get 38 degrees. So we know each of these angles, so angle A is 38 degrees, and angle B is also 38 degrees. Okay, so that's one step of the puzzle. So how exactly can we find angle this X, right? So one way I'm looking at it right now is it's on this line right here, and we can use what's called the supplementary angles, right? Because two angles on a straight line will have to equal 180 degrees. So if you find this angle right here, angle DEB, whatever that is, if we find that value, then we can just subtract 180 minus that value, and then we get whatever X is going to be. So is there a way to find angle DEB? Well, it's actually pretty interesting because they gave us the measure of EBC, this angle up here, and we just figured out the angle of BDE. And so these two angles make up a portion of this triangle, right? So it's this triangle right here. Boom, boom, boom. Oops. This triangle. All right. So we know there is, let me just switch back. There is 180 degrees in a triangle. So if we found two of the angles, 45 degrees and also 38 degrees, then we can find the last value. And this last value, let's do some quick maths. I think that is 97 degrees. Okay, so angle E is 97 degrees. All right. All right, so as we said before, now we can use supplementary angles. So we know these two angles, this angle we just found here, 97 degrees, and angle X, together they will have to equal, so 97 degrees plus X, whatever that is in degrees, has to equal 180 degrees. And so we can do some simple maths. 83 is our final answer. So the value of X would be 83 degrees. And I think they want you to represent it as just the value without the degrees, because they already state the degrees here. And so if you're really finding X, the actual answer is just 83. So it says, in the figure shown, points Q, R, S, and T lie on the line segment PV, and line segment RU intersects line segment SX at point W. The measure of angle, so I'm going to mark this down, of angle SQX is 48 degrees. So let's write 48 there. Okay. And the measure of angle SXQ is 86 degrees. So let's write 86 there. Okay. The measure of SWU is 85 degrees. So let's write 85 there. Boom. And the measure of VTU is 162 degrees. And the problem says, what is the measure in degrees of angle TUR? So this is the angle we're trying to find. So let's see. So they give us a bunch of angle measures, and now we just have to implement theorems that we know in order to find those missing angle measures. So the first thing I want to point out here is that we have two angles on a straight line, right? So we have angle VTU, which we know is 162 degrees, and this angle UTS. So this angle right here would just be 180 minus 162. All right. So 180 minus 162 is just 18 degrees. So we know that this angle right here has to be 18 degrees. And so why did I find that angle? Well, because in order to find angle TUR, I want to highlight this. What we can do is actually just find two of the angles in this triangle, because we know there's 180 degrees in a triangle. So if we find this angle, the one we just found, the 18 degrees, oops, switch. If we find this angle, and we also find, let's say, this angle in the corner, then we can just do some math to find the missing angle. So is there a way to find angle TRU? Well, it is a part of another triangle right over here. And so now we really have to think, what can we do? So first off, we have this 85-degree angle here, and we have a very straightforward vertical angles theorem here. So this angle right here, which is across from the 85 degrees, that is also 85 degrees. And now another thing I want to note out is that this quadrilateral QRWX has 4 sides, right? And it's a closed shape. So because of that, I just want to highlight this. This will have 360 degrees, right? And so what we've just done is we found 3 of the angle measures. So we found 85 degrees, and then we found, well, we didn't really find this, they gave it to us, 86 degrees, and then they also gave us that 48 degrees. And so now if you want to find this angle in the corner right here, angle QRW, we just have to subtract 360 minus all those other angles. And so that gets us 141 degrees. Now, what does that really help us find? Well, first off, it's getting a little messy over here, so I'm just going to erase a bunch of this. So now we've found that this angle right here is 141 degrees, right? And again, that we have 2 angles on a straight line. So that has to equivalent to 180 degrees. So what is this angle right here? Well, that's just 180 minus 141. And 180 minus 141 is just 39 degrees. And so, if we find this angle TRU, we now have 2 missing angles. We found the 2 missing angles of the triangle that we initially wanted to find, which was this one right here, right? So we know that because a triangle has 180 degrees, then we just found the 39 degrees in this corner right here, 39. And we already found this one from the other calculation we did of 18 degrees for this angle. So we can just add these together, subtract it from 180, and we get 123 degrees. Yeah, that is our final answer for the measure of angle TUR. It says, in right triangle RST, the sum of the measures of angle R and angle S is 90 degrees. So angle T is the 90-degree angle. The value of sine R is square root of 15 over 4. What is the value of cosine S? So let's draw a right triangle here. So you know R, just put up here, angle S, and T is the 90-degree angle. All right. So the value of sine R, so sine, we know, if you know SOHCAHTOA, is opposite over hypotenuse. Oops. Opposite over hypotenuse. So if we look at this angle measure, the opposite side length of this angle is over here. So this value will have the square root of 15. And then the hypotenuse would just be the hypotenuse of the triangle, which is RS. So here we would have a value of 4. I just want to erase this arrow. Okay, perfect. So now it's asking, what is the value of cosine S? So if you zoom in here on angle here, of angle S here, cosine is equivalent to adjacent over hypotenuse. So the adjacent value, we know of the adjacent value for angle S would just be square root 15. So in our answer, square root 15 should be on top. But what is the hypotenuse, right? Well, we don't even need to do any calculations because we know the hypotenuse we already calculated, which is 4. And so it's square root 15 over 4. Our answer is B. During a month, Morgan ran R miles at 5 miles per hour and biked B miles at 10 miles per hour. She ran and biked a total of 200 miles that month, and she biked for twice as many hours as she ran. Was the total number of miles that Morgan biked during the month. So there's a couple ways you can approach this, but I think the simplest way is honestly just through ratios and systems of equations. So first off, we have 200 miles that she runs in total. And we can set this equal to R plus T, because that's the total mileage that she ran, right? The number of miles she runs and the number of miles that she bikes. So now we want to set up a system. So in our case, we should have a variable. We'll call this X. So X in our case, let's say, is the total number of hours that she spends on the activity. So in our case for running, we can just say 5x, right? So in our case, if X, let's say she spent 2 hours doing that activity. If she spent 2 hours running, it would be 2 times 5. And so that would check out. So if she ran for 2 hours at a rate of 5 miles per hour, guess what? She's going to run a total of 10 miles as her distance. Now, if we zoom in now for biking, that's a different story. Now, why? Well, first off, her rate is different, right? So instead of going at 5 miles per hour, she's going at 10 miles per hour. So it really doesn't matter whether she's running or biking, but it's only the speed that changes. And also if you have an external variable, which in our case we do, because she says that she biked for twice as many hours as she ran, right? So we can't just write 10x here because we know that she biked for twice as many hours as she ran. And so we can put a 2 on the outside here, multiplied by the rate of 10x. So 10x is just the amount of time, or rather x is the amount of time she just spends in activity. So watch what happens. So we have 5x plus 2 times 10x. So this becomes 20x. And this is 5x. So this becomes 25x equals 200, right? And so if we solve for x here, we get 8. So 8 doesn't have a really meaning in this problem, but if we plug this in to each of our rates, we can actually find the answer. Now, why? Well, because we can plug this back into the 5x here. So we know that she runs 5 miles per hour. So if she's doing x activity for 8 hours, that's going to give us 8. So that's 40. That's 40 miles. And we know in total, she ran and biked a total of 200 miles. And so 200, boom, boom, minus 40 is 160 miles. And so that is our final answer. And there's another way you can check. Using this equation right here, 20x. So 20 times 8, right? That value of 8. And guess what? That also gets us 160 miles. And so our final answer is D. It says, the equation above is true for all values of x that is greater than 2, where r and t are also positive constants. What is the value of r times t? Okay, so this is a rational equation, and so we want to get rid of the denominator, right? So if we're trying to find a way to get rid of the denominator, we need to find a common denominator. So here it is pretty obvious, because on the right side we have x minus 2 times x plus 5. Whereas each of these standalone variables are missing one part of that, right? X minus 2, we can add a x plus 5 to that. And at x plus 5, we can add a x minus 2 to that. So I'll show you how it works. So for this one, 2 over x minus 2, if we multiply this by x plus 5 over x plus 5, we get the following. We get 2 times x plus 5, x plus 5 over x minus 2 times x plus 5. So whatever we do to the denominator, we have to do to the numerator, because x plus 5 over x plus 5 is 1. So in reality, we're not doing anything to it, but we're just giving it the same denominator so we can cancel it all out at the end. So the same thing is going to happen to the second term. So we have 3, and the common denominator here that we want to add is x minus 2. So 3 times x minus 2, be like that. And then we would have x minus 2 times x plus 5, and boom. And this is going to equal rx plus t. And because we already have this here, they list us, they give this to us. So this is all going to be the same, x minus 2 times x plus 5 as the common denominator. And so what we can do is just get rid of it. So all this at the bottom dies. And so now we're left with the following on top, 2 times x plus 5 plus 3 times x minus 2 equals rx plus t. So now we want to distribute this out. So 2 times x is 2x, and then 2 times 5 is 10, and then we add 3 times x, so 3x, and then 3 times negative 2 is negative 6, equals rxt. And this simplifies further, and it's actually kind of cool what happens. So we have 2x plus 5x, we're just combining like terms, and then 10 minus 6 is plus 4. So if we look at this, what you'll find is that on the left side, we have a x term and a constant, right? On the right side, we also have an x term, rx, and a constant t. So in our case, for r, we can just substitute in 5, right? So if r is 5, we get 5x, and if t is 4, we get 4. And that's kind of funny because left side, 5x plus 4, right side, 5x plus 4. Those two are equivalent, and so we know r is 5 and t is 4. And so if they want us to find the value of r times t, 5 times 4 is positive 20, and so our answer is C. Function P models the population thousands of a certain city 2 years after 2005. According to the model, the population is predicted to increase by n% every 18 months. What is the value of n? All right, so first off, we want to know how much it increases every 18 months, but in our equation, t is represented by years, and so we want to convert this 18 months to years. So 18 months is just 1.5 years, right? And so now what we can do is just plug 1.5 into our equation, and it's actually funny because 4/6 times 1.5 gives us 1, right? So in reality, when we raise the 1.04 to a power of something, we're raising it to a power of 1. And so this is all non-negligible when we're doing this calculation. 290 is our constant, so we start off with 290,000 as our population. And then 1.04 is actually that, I guess I'll call it like the factor that you apply, the growth factor. So this 1 right here represents obviously the initial amount. So let's say it was 1.0, that means the population would just stay the same at 290. But because it's greater than that, it's 1.04, what this represents is a 4% increase, right? So if it was, let's say, 1.1, that would be a 10% increase. And so we know right here, it's a 4% increase. So if we're looking at here, the question says, according to the model, the population is predicted to increase by n% every 18 months. The value of n is what? Well, we said n would be 4%. So the answer here is C. It says for the linear function f, the table shows 3 values of x and their corresponding values of f of x. Function f is defined by f of x equals ax plus b, where a and b are constants. What is the value of a minus b? All right, so they give us, it says they give us 3 values of x. And so what we can do is actually make the function, right? Let's plot it out. So we have f of x, and so now we have to find out what the slope is. That's what the a represents because it's right in front of the x. All right, so to find that, we just want to look at the difference in between. So it's rise over run. So from negative 64 to 0, that's an increase of 64. And from 0 to 64, that's an increase of positive 64 as well. And we can see for that each positive increase of 64, so that's a change in y, our change in x is just plus 1, right? So we can determine that our slope is 64x. All right, so now we want to determine b. So b is the y-intercept. And so the y-intercept is the value you get when x is 0. Now it's not on here, but we can predict what it is. So we know that the difference between 1 and 0 is a x value of 1, right? So plus 1 here. And so we can just work backwards. So instead of adding 64, we can just subtract 64. And so here, minus 64, we'll get a value of negative 128. And so our x-intercept would be 128. So you could write this as plus negative 128, but it's the same thing. So it says, what is the value of a minus b? So our a value is 64, all right? And it's subtracting the b value. The b value is negative 128, all right? So if you subtract a negative number, we're essentially adding it. And so 64 plus 128 is just 192, so that's our final answer. The circle above has a center O. The length of arc ADC, the minor arc, is 5 pi, and x equals 100. What is the length of arc ABC? All right, so if we look at this, what we want to do is set up a ratio, right? So the first thing we know is that the angle x is going to be corresponding with that arc ADC. So our angle x
we can just write this on top, would be 100, right? And so it's corresponding to arc ADC, which has a length of 5 pi. And so now they want us to determine what is the length of arc ABC, right? This side right here. This side right here, right? So because we know that the circle is split up quite evenly, right? The degree value over here is going to correspond with that arc length of ABC. And so can we determine that angle? Well, we can't, because we know there's 360 degrees in a circle. And so if angle X is 100 degrees, we're left with 260 degrees, right? So this will go on top. And so now we can actually pretty easily figure out what our length of arc ABC is by just finding this corresponding value, right? So to do this, we have to do some simplification, or we can just find the factor actually, right? So from 100 to 260, that is a scale factor of 2.6x, or 2.6 times. And so we can assume that for the same thing on the denominator, to keep this ratio constant, we also have to multiply this by 2.6. And so here we can just do 5 times 2.6 pi. And that's the same thing as multiplying 5 pi by 2.6. So 5 times 2.6, that will give us 13, right? And then we can just add the pi at the bottom, or next to it. So we get 13 pi as our final answer.
If square root of x to the 5th over cube root of x to the 4th equals x to the power of a over b for all values of x, what is the value of a over b? So first off, for this radical up here, for both of these radicals actually, we can simplify it and rewrite it. So square root of x to the 5th using exponent properties and radicals, we can determine that it is just 5 over 2 as the power, because in the denominator, that's just the index of the radical, and then whatever's under that square root or the power of the base goes in the numerator. And so this goes over this term, so this x, and this can be rewritten as just 4 over 3. And so now we want to find a common denominator here between 5 halves and 4 thirds. And so we can just multiply this by 3 and this by 2. So this would be x multiplied by 3, so you get 15 sixths. And then we multiply this by 2, so you get 8 sixths. And so now, because we have the same base, we can just subtract the powers. So 15 sixths minus 8 sixths is just 7 sixths. And so ultimately, they want to find the value of a over b. We can see a over b is just the power above x, and there is your answer. So the answer here is 7 over 6. The xy plane, the graph of y equals x squared minus 9 intersects the line P at 1a and 5b, where a and b are constants. What is the slope of line P? Alright, so here's the thing, right? Since the graph of this equation y equals x squared minus 9 intersects with line P, and we are given the x coordinates of yp of line P, what we can do is plug in these x coordinates into the equation, find our y value, and since we know they intersect, then those coordinate points must be the same. And so whatever y value we get, we can just put it in for a and b. So I'll show you how it works here. So here, x squared minus 9, for x, we can just plug in 1, minus 9, and therefore we get negative 8. And then same thing over here for the second coordinate point, you get 25, 5 squared is 5, oops, go. So we get 16. All right, so now we have the two coordinate points, right? We have 1, negative 8, and 5, 16. But they want to find the slope of line P. So that's just rise over run, or change in y over change in x, right? So our change in y is from negative 8 to positive 16. So that's going to be a difference of 24. And so 24 will go on top here for our change in y. And now our change in x is just between 1 and 5. So to go from 1 to 5, that's a change of 4. Positive 4. So ultimately our slope
is 6, and so our answer choice is number or letter 8. Figure above, side BD is parallel to side AE. What is the length of side CE? All right, so first off, we have two triangles, right? We have triangle EAC and also triangle DBC. So the first thing to notice here is that there is similarity present between these two triangles. Now why? Well, because of angle, right? So for this first triangle, triangle EAC, it has that 90-degree angle in the corner. And we can see that for the other triangle, triangle DBC, it also has a 90-degree angle, which is formed right there. And now where is that other corresponding angle? Well, highlight it here now. It's going to be this angle C right here, right? So it's going to be present in both triangles, and therefore it makes the theorem of similarity true. And so knowing that these two triangles are similar, we know that the side lengths are going to be corresponding. And so in that case, we can scale up whatever numbers we already know based on a scale factor, based on the numbers that were given, in order to find the missing side length. So here, we're trying to find CE, so this side right here. Oops. So, my God. Cannot draw today. All right, so first off, what is the scale factor? Well, we know the two corresponding sides here, we can look at right here, 6 and 18. So that's a scale factor of 3 between those two triangles, right? And now we just want to find the missing side length CD, because if we find that, we're going to scale that up in order to find CE. So CD, well, it's going to be equivalent to, we can just use Pythagorean theorem. So we'll just say 6 squared plus 8 squared equals C squared. So we get 6 squared, 36 plus 64 is 100. And therefore, C squared. And then if we take the square root of both sides, we ultimately get C equals 10, right? So in our case, C would just be the side length of side CD. And because we know the scale factor is 3, we would have to apply the scale factor to our value of 10. And so ultimately, our final answer for the length of side CE would be 3 times 10, which would be 30. So it says in the xy plane, a parabola has a vertex of 9, negative 14, and intersects the x-axis at 2 points. If the equation of the parabola is written in the form y equals ax squared plus bx plus c, where a, b, and c are constants, which of the following could be the value of a plus c plus c? A plus b plus c. Okay, yeah. So definitely a lot of constants. But so first off, we see that it has a vertex. It gives us the coordinates of the vertex, and then it says that if it's written in the form of just y equals ax squared plus bx plus c, the standard quadratic form. So this is a screaming vertex form, right? Because we need to convert what we know, the information we know with the actual values, which is the vertex, into that quadratic. So here's how we would do it. So we have that vertex form. So vertex form would be y equals a times x minus h squared plus k, all right? So in our case, we would have y equals, we don't know what the a value is, so we'll just keep it as that. X is just x, and then our h value, so 9 is our h value, and then negative 14 is our k value. So 9 here goes here, so minus 9 squared, and then plus negative 14 is just negative 14. All right, so now that we have this, what we want to do is just expand it out. We don't have the a value, but that's okay, because you'll see in a second, it actually doesn't matter. So y equals a, and then x minus 9 squared would just be ax squared. I actually want to put this in the parentheses. So x squared minus 18x plus 81. And then we have the negative 14 on the outside. But now notice how the a times x minus h squared, the a is attached to it. So then we need to distribute the a again to each of these terms. So then we get y equals ax squared minus 18ax. And yeah, guys, make sure you try the problems on your own, all right? But yeah, 81a. And then we add, and then we add negative 14 at the end. All right, so now we have our quadratic equation, right? But the problem is we don't know what A is. So the problem is if we don't find A, it doesn't really work out. But do we need to find A really? Well, you'll see in a second. So first off, let's label each part of our equation here. So the ax squared, that is our A value. This negative 18ax, that's our B value in this equation. And then the 81a minus 14 is our C value. So here's the thing, right? We can put everything in terms of A and just negate the x squared, the x, those values, because those don't actually account for the sum, right? We're only looking at the value of A plus B plus C. So it doesn't matter if it's 2x squared plus 3x, 2 plus 3 is 5. So what we can do is write this as in terms of A. So A would just be A, right? Because we're just canceling out the x squared, we don't care about it. So A is A, now we have to write B. So now we want to add the B value, which is negative 18a, right? So really we're subtracting negative 18, but there we go. And now we want to add the C value. Now our C value is this entire thing, and there's no x value, so we can just write it in terms of the entire thing. So there we go. We get this long equation. If we simplify this down, what we get is 64a minus 14. All right. So this right here, 64 minus 14, this represents the sum of A plus B plus C. All right. So now how do we determine what could be a possible value, right? Like how do we actually get our answer choices? Well, we actually have to go back into the question and look at what was given. So it says that it's a parabola with a vertex of 9, negative 14. It says it intersects the x-axis at 2 points. All right, so if we draw this out, this is very helpful. Draw this out. The vertex 9, negative 14 is going to be in quadrant 4. So it'd be like down here somewhere, right? So if it intersects the x-axis at 2 points, that means the parabola has to open upwards. And that means the A value must be positive, right? So if it intersects, it can't be like this, right? It can't be like this because the vertex then would be up here, which makes no sense. So what it has to look like is like something like this, right? Boom. Very straight, curvy parabola, but whatever. So now what we want to do is just set this equation right here equal to each of our answer choices. You'll see something very interesting. So this is going to be a very long process because I'm using my mouse, but yeah. So we set this equal to 23. And yeah, feel free to skip ahead if you don't really want to see me write all this out. But I just kind of have to like prove my point. But yeah. I appreciate any of you who keep watching for the YouTube algorithm. All right, negative 14. I'm doing the best I can right now. I'm trying to write as fast as I can, but there's limitations. Negative 14. Okay, that is just straight up messy, but okay. So now we know that in order for our A plus B plus C to work out, the A value has to be positive. So we'll just find the A value for each of these equations and see if it works out, right? So we'll just work from top to bottom. Boom, boom. So first off, for our first equation, if we just do some simple algebra, we can add 14 on both sides. But negative 23 plus 14, that's going to give us a negative value. So if we have a negative value and then you isolate for A, a negative value over 64 is going to give you a negative value for A. So this cannot be our answer because it'll be negative. It's the same case with the very next one, right? Negative 19 plus 14 is negative 5. Negative 5 over 64 is negative, so it can't be this one. And then right here, it's a very interesting case. You have negative 14 and negative 14 on both sides. So if you add positive 14 on the left side, you'll get 0. 0 over 64, that's not a positive value, right? You get 0. So it can't be this one either. And so our last one, very cool. You add 14 on both sides, and guess what? You get a positive value, right? You get 2 right here, and then you get 64a. And guess what? If you isolate for A would give you 2 over 64, and 2 over 64 is a positive value, and therefore it satisfies this up here, it satisfies everything else, and this is our correct answers. XY plane aligned with equation 2y equals 4.5 intersects a parabola at exactly 1 point.
if the parabola has equation y equals negative 4x squared plus bx, where b is a positive constant, what is the value of b? All right, so first off, I'm just going to say this. You can solve this very easily with the Desmos calculator, and I'll show you how to do that. However, I'm going to show you how to do it algebraically. That way, in some cases, when College Board comes up with a question that you can't just solve using Desmos, you're not cooked, right? So let's actually solve this legitimately using some algebra. So we know that this is going to be a system, right? Because they intersect at a point. And because it's a line that intersects a parabola at exactly one point, we know that it's going to be intersecting at its vertex. So first off, let's just get them both set to each other. So for this top portion, we have 2y equals 4.5. Let's rewrite this as y equals 2.25, right? So now since both of these, this one up here and this right here, they're both y equals, we can set them next to each other. So 4x squared plus bx, we can now say that is equivalent to just 2.25. You'll find we'll get a quadratic, which has the actual c value. So this becomes, let's write this out, negative 4x squared plus bx minus 2.25. And so now in order to solve this problem, what we need to do is actually tap into the quadratic formula. So in the quadratic formula, there is this part called the discriminant, and that is the square root of b squared minus 4 times a times c. All right, so why is the discriminant important? Well, because the discriminant actually tells you the number of solutions that are in the quadratic. So our a value is negative 4, our b value is, we don't know, that's what we're trying to solve, and our c value is negative 2.25, right? So the thing with the discriminant is that if it is a positive value, you're going to have 2 real solutions. If it is equal to 0, you're going to have 1 real solution. And if it's negative, you're going to have 0 real solutions. So since we know it intersects at the parabola at exactly one point, we know that it has to have 1 solution. If this doesn't make sense, I'll clarify later when we actually show you how to do it with the graph. So right here, we can just write this out because we know the a and c values. So right here, we have b squared. We don't know what b is. We know it's minus 4. Then a is just negative 4. Oops. A is negative 4. And c is negative 2.25. So we can calculate this out, and this is what we will get. We'll get b squared minus 36. All right, so now we have b squared minus 36, right, under the discriminant. So we talked about how if the discriminant was equal to 0, there would be exactly 1 solution. So that's what we want. We want the discriminant to equal 0. So if we want this to equal 0, it's pretty simple, right? So under the square root, we just want 36 minus 36, which would equal 0, right? And the square root of 0 is 0. So here we know that b is 6, right? And b6 is our answer in this case, is the positive constant. So that is how you solve that, but I also want to show you a much easier way and also explain it a little more in case you didn't understand that explanation. So let's move over to Desmos, and I do need to adjust the camera a little bit. So here what you'll see is that what I've done is plotted y equals 2.25, right? Because it's a system, I'm setting both of the equations onto the graph, and then that y equals negative 4x squared plus bx. But what Desmos does is it reads b as a constant, right? So what you can actually do, here I'll remove this, you'll say, when you add plus bx, you'll say add slider. Now you want to click that add slider, and guess what? Now you can just move this and adjust the value without having to plot and guess and check a bunch of times. So here we have the blue is the y equals 2.25, and then our y equals negative 4x squared plus bx is going to be our quadratic. So we want to just move the slider until it hits the vertex, until our parabola hits that line, right? So if we move this over, and we can see that around b equals 6, it intersects, and the system intersects there at the vertex exactly. And so now that is a way you can easily figure out that b is equal to 6 in a matter of seconds. Now, another thing I want to point out is I want to bring this bottom graph up. So the reason in the when we solved it algebraically, the reason we did negative 4x squared plus 6x minus 2.25 is you'll notice that we were able to use the property of the discriminant to determine how many solutions it would have, because here you can see there's multiplicity, right? So there's only one real solution here at 0.75 comma 0, right? So there's one solution here. But this equation right here is the exact same thing. The black one is the exact same thing as the green one, except that there was a different constant, right? There was no constant up here in the green one, whereas this one was just shifted down 2.25 units. So in reality, we know that what we're doing is we're treating that y equals 2.25 line as y equals 1, right? In this case, with the green one, the y equals 2.25, the one solution was just there, right, at the vertex. Whereas for the black one, it's the same thing, right? Think about the y equals 0 line as just that y equals 2.25 line. And since it only intersects at one point right there at 0.750, we know it can only have one solution, right? So we can add 16 on both sides when we set it equal. So we can just skip that step and put plus 16. Boom, plus 16. All right, there we go. So what we're trying to find is the least possible value of k, so the coefficient in front of our x squared term, and the equation has no real solution. So when it is a no real solution question, or maybe it's asking, oh, if it has one solution, then you're always going to be looking at the discriminant when dealing with that quadratic. So the discriminant is just b squared minus 4ac, right? So basically what happens with the discriminant is that when the discriminant is equivalent to a negative number, there's going to be no real solution. Therefore, now that we have the values, we should just plug it in. So in our case, we know what b is. Our b value is negative 56. So negative 56 squared. Oops. Negative 56 squared. And then we're going to have our c value, which is 16. So our a value first. So our a value is k. So we don't actually know what that is, but we know our c value is 16. This is what's interesting. Now we have everything out here. So negative 56 squared is going to give us 3,136. And this will be equivalent to, we do 4 times 16, so negative 64k, right? So this is our discriminant right now. As we said before, we want this discriminant to be negative, but it also has to be the least possible value of k. And it's an integer value, so we don't want any decimals, right? So first off, let's just find the value of k that makes this 0, right? So in our case, the square root of 0, what would make this 0? Well, k would have to multiply by 64 to give us 3,136, right? So in this case, k would then be equivalent to a value of 49, right? So if k is equivalent to 49, we would have 3,136 minus 3,136, and then we would only have one real solution. But in our case, we want no real solutions. And so we'll just take one integer value above 49, and we will get k equals 50, right? You can check this. 64 times 50, subtract that away from 3,136, and you'll indeed get a negative number. And therefore, our answer for the least possible value of k for the no solutions of this equation would be 50. Square A has side lengths that are 166 times the side length of square B. The area of square A is k times the area of square B. What is the value of k? So it's a very straightforward question. You can draw a diagram if you want to visualize it. So I'll just draw two squares. So let's call this one square A and this one square B. All right, and we know the side lengths are 166 times the side lengths of B. So if the side lengths of B are x, call it x, then A would be 166x. I'll just put those on both sides. And so to find the area of a square, we'll just do length times width. So if we have x times x, that will give us x squared. And then we want to set this in proportion to 166 times 166x. So that's going to give us is 27,556x squared. All right, so now we want to compare these two numbers, right? Because this is the area of square B, and then the one on the bottom is the area of square A. So how can we compare? Well, we can just plug in a random value for x. So let's say the side length of B was 1, right? So then we would get 1 squared. 1 squared is just 1. And then since 1 squared is 1, then we know for the bottom part, this is just equivalent to 27,556. We can clearly see the relationship here that the area of square A is 27,556 times. So ABC above is our right triangle, and sine of B is 5/13. What is the length of side BC? Alright, so pretty simple problem here, except there is a little caveat that we have to take consideration of. So first off, sine B, I've marked the angle B. We know SOHCAHTOA, which is so sine represents opposite over hypotenuse. And so the opposite side would be a side length of 5. However, the interesting thing here is that it says the hypotenuse is a length of 13 when it's clearly marked 26 on our diagram for side AB. So what is happening here? Well, basically what we need to do is scale it up, right? Because if it's something that can be condensed down, it can be, and it's still mathematically correct. But so I'll show you the case here. So in reality, our actual length is 26, right? But our fraction here is 5/13. So what we can do is scale this up for the actual side length of AC. So since 13 times 2 is 26, then we can do the same thing to 5. 5 times 2 is 10, and so AC is a length of 10. So there we go. So we know that AC is 10, and now we want to find the side length of BC. So we don't know what BC is, but guess what? It's a right triangle, and so we can use Pythagorean theorem. So Pythagorean theorem is A squared plus B squared equals C squared, right? And we know it doesn't really matter. I guess I'll call AC or A value. So we have 10 squared plus B squared equals 26 squared. Alright, so 10 squared is 100 plus B squared. 26 squared is going to be 676. And so if we just rearrange this equation, we get B squared equals 576. And if we take the square root of both sides, we can find that B is equivalent to 24. And therefore 24 is our answer, in which case that is the side length of side BC. The equation above defines a circle in the xy plane where the coordinates are the center of the circle. So I've written out the actual circle equation out here. You can see that our current equation doesn't match that. So we can't really base our coordinates here. So we can't take 20 or 16 or any of that. But essentially to find our coordinates, we know that H and K represent the coordinates of the center of the circle. So first off, we need to convert the top equation to our standard circle equation form, right? And the way we're going to do this is to find a perfect square trinomial. And we can do that by completing the squares. So let's start off with x squared plus 20x. And to complete the square, what you're going to do when there's not a coefficient in front of the x squared term, let's write this out, -20, is you take half the b value. So in our case, the b value for this first x squared part is going to be 20. And you can take half of that and square it. So half of 20 is 10, and you square it, that's 100, right? And we want to add it here. And so whatever you do to one side, you want to do to the other side, right? To keep the balance so you're not manipulating the actual equation here. So then we have the second part. I'll switch colors for this. Let's use blue. Plus y squared plus 16y. And so we're going to do the same thing. Take half of the b value. 8 squared is 64. So we add 64 to both sides. And so now we can actually get it into our circle equation form, because watch what happens. So here, this is going to factor out to just x plus 10 squared. All right, and this side is going to become y plus 8 squared. And this thing over here, this computes to 144. Now it matches up with the circle formula, right? This is 144. That's messy. All right, 144. There we go. So now we can actually find the value. So we know that it can't be any of these. It can't be 20 and 16, right? So is it positive or negative? Well, in our actual equation, it's positive 10 and positive 8. Does that mean those are the coordinates of the center of the circle? Well, no. Because if we have a positive here, what that means is that h is negative and k is negative. Now why? Well, I'll give you a quick example here. So if you have x minus, this is the standard form, it had a negative value of h, it'll look like this, right? You're subtracting a negative, which gives you a positive, as you can see here. And therefore, our answer here is just 10, 8. In the figure, line M is parallel to line N, and line T intersects both lines. What is the value of x? All right, so first off, what we have here are vertical angles, right? So they give us 33 degrees here, so we know the angle across from that will also be 33 degrees. So if we call this angle right here that we just labeled angle 1, what we can see is that angle 1, and let's call this one angle 2, angle 1 and 2 are supplementary angles, right? Because two angles that make up a straight line will be equivalent to 180 degrees. And so if we know the total between those two angles is 180 degrees, and we just found angle 1, right? Then we can find angle 2. And so angle 2 here will be 147 degrees. And this is helpful because we have two parallel lines cut by a transversal. And so we have our corresponding angles. Angle 2 that we have here and I guess angle x here, they are corresponding angles, and so they will have the same angle measure. And so since we know angle 2 is 147 degrees, x is also going to be 147 degrees, and so our answer choice is D. The function f is defined as f of x equals negative 8 times 2 to the power of x plus 22. What is the x-intercept of the line y equals f of x in the xy plane? All right, so first off, the number is probably jumping out at you, the plus 22, but don't fall into this trap. You know, there's always that answer choice that they want you to pick, but it's really just a trick answer. So instead of jumping to conclusion, seeing this plus 22, it's saying, this, everything else here is being multiplied and it's dependent on x. But something you'll notice here is that the y-intercept is the value you get when x is 0, right? So if we look at this more closely, 2 to the power of 0 is really just 1, right? And so 1 is going to be multiplied by negative 8. So 1 times negative 8, and that gives us negative 8. So in reality, we have negative 8 plus 22. And negative 8 plus 22 is going to give us 14. All right. So 14 here is going to be our y output when x is 0. And therefore, our answer choice is going to be A. Which expression is equivalent to 4 over 4x minus 5 minus 1 over x plus 1. So we have a bunch of answer choices here, and the first thing we want to do to simplify this for equivalent expressions is just get the same denominator, right? That way it's easier to work with, and we can actually do some arithmetic when it comes to it. So we see here that in the first term, we have 4x minus 5 at the denominator, and then for the second term, it is x plus 1. So we can do pretty easily is just find a common multiple between these two terms, and we can just do that by multiplying 4x minus 5 by x plus 1, and then vice versa, multiply x plus 1 by 4x minus 5. And by doing that, we also have to do the same thing to the numerator. So let's see how that works. So we have 4 over 4x minus 5, and we will be multiplying this by x plus 1 over x plus 1. You can see how that in reality that we're just changing both the top and bottom of the fraction, because x plus 1 over x plus 1 is really just 1. And so here we'll get 4x plus 4 over 4x minus 5 times x plus 1. And so now we'll just want to do the same thing to the other side. So here we're going to have this term right here, 1 over x plus 1. We're going to be multiplying this by 4x minus 5 over 4x minus 5. And so therefore we will get 4x minus 5 over, and then we get x plus 1. So that's just going to be the same thing, 4x minus 5, and then x plus 5. And so now we can also just look at this entire thing over each other, right? So we have 4x plus 4 minus 4x minus 5, but they have the same denominator. So in reality, this can just be rewritten as 4x plus 4 minus 4x minus 5. over all of this. So let's write it out again. Kind of tedious, but you gotta do what you gotta do. You'll see pretty interestingly is that some of the answer choices have this denominator. So we know we're on the right track here, right? So let's just evaluate the top part, right? So with 4x minus 4x, those two are going to cancel, right? So that's just going to be 0. But now in our case, we have 4 minus negative 5. So we're really just adding 5 to 4. That's going to be 9. So you have 9 on top, and then 4x minus 5. Really messy, but whatever. X plus 1. And so we have our equivalent expression right here. And we can see that actually matches up with answer choice D, and therefore that is our answer. Cube has a volume of whatever that is, cubic units. What is the surface area in square units of the cube? All right, so the first thing to recognize here is that a volume of a cube is just length times width times height, right? We all know this. So the thing to recognize here is that for a cube, it's made up of squares, right, as the faces. The special thing about squares is that each of the side lengths are equal, right? And because of that, we know that the length has to be equal to the width, has to be equal to the height. And therefore, in order to find the actual values of either the length, width, or height, what we can do is just take the cube root of the volume, which is going to be 474, 552. And that will give us a value of 78, all right? So 78 is just the side length of each of the sides. And now we want to calculate the surface area. So for the surface area, we can just find the area of each side and then multiply by the number of sides. So we have 78 times 78. That will give us the area of one side. And we know there are 6 faces to a cube. And so we can just multiply this by 6, giving us a final value of 336,504. The function h is defined by h of x equals 4x plus 28. The graph of y equals h of x in the xy plane has a x-intercept at a, 0 and a y-intercept at 0, b, where a and b are constants. What is the value of a plus b? All right, so first off, you guys can just plug this equation into Desmos, find the x and y intercepts, their corresponding x and y values, and then add them together, right? But we don't want to endorse, becoming reliant on Desmos, so let's just solve this algebraically for fun. All right, so first off, let's start off with that x-intercept, right? So the x-intercept, as you can pretty easily deduce from this, is what value of x will give you a output of y equals 0, right? So here we can just say 4x, which is going to be our h of x function. And we want to set this equal to 0 because we want the output to be 0, as you can see right here. So here we can just subtract 28 on both sides. So we get negative 28 equals 4x. And then we'll divide both sides by 4 to isolate for x. And so we get x equals negative 7. All right, perfect. We found the x coordinate of our x-intercept. And now we want to find the y-coordinate of our y-intercept. And so for this part, it's pretty much the same thing, but reversed, right? We want to find the y output when x is equivalent to 0. So here we'll just put 4, and then we know x has to be 0. So 4 times 0 plus 28. Well, 4 times 0 is just 0. So if you add 28 to 0, you're going to get 28 as your final answer. And so 28 will be equivalent to our y coordinate. And so now the question says, what is the value of a plus b? So the value over here, negative 7, is our a value, and then positive 28 is our b value. And so if we add them together, negative 7 plus 28, that's going to be equivalent to positive 21, and so A is our answer.
Triangles A, B, C, and D, E, F are congruent, where A corresponds to D, and B and E are right angles. The measure of angle A is 18 degrees, whereas the measure of angle F. All right, so we know that these are right triangles, so let's just draw them out. So our first triangle is going to be, looks like B and E are the right angles, so I'll just put B here and A up top. And then call this one C. And we'll do the same thing, and these are congruent triangles, so just, they're not really the same size here, but just imagine they are. Alright, so E is the other right angle. Alright, so this one's D, and this one's F, Yeah, let's mark those right angles in there. It's pretty messy. And there we go. All right, so let's see what's given. So they say that the measure of angle A is 18 degrees. So we have 18 degrees right here. Boom. All right, so here's the thing, right? We know that right angles are 90 degrees. So angle B is going to be 90 degrees. And so they want us to find the measure of angle F, and angle F is in the other triangle. But since we know they're congruent triangles, we know that their corresponding angle is going to be the same, right? Not only are they like similar in terms of side lengths, but they're also going to have the same angle measures. And so if we look at this corner right here, the angle of C can actually be found by just adding up the angles of A and B and then subtracting it away from 180 degrees. And the reason for that is because there's 180 degrees in a triangle, right? So 180 minus 18, well, let's just minus 90 first, and then minus 18. Boom. So that will give us 72 degrees. And since we know that C is 72 degrees, and its corresponding angle matches up to angle F, that means angle F must have a measure of 72 degrees. How many points in the graphs of the given equations intersect in the xy plane? Well, we have the two equations on the right side. You can see they have the exact same slope, right? 2x. And then they have different y-intercepts. This one's plus 10 and this one's negative 1. So if you were to graph this, what it would look like is just two parallel lines, right? So the first one go through like this, intersect at 10, and keep going. It's a linear line. The other one would come across. It's going to be intersecting at negative 1. And so you'll see because they have the same slope, but different y-intercepts, that means they're never going to cross each other. And so if they never intersect, that means there's no solutions to this system. And so our answer is going to be A0. The given equation relates the variables x and y. For what value of x does the value of y reach a minimum? So here, first off, this is a quadratic equation, right? And it wants us to find the value of x when y reaches its minimum. We can see that the positive coefficient in front of x squared is positive, and therefore it's going to open up that parabola. And so it makes sense that we're looking for the minimum, because the minimum here is going to be that vertex, right? And so if we're looking for the x value of the vertex, that's just the x coordinate of the vertex, and therefore we can actually use the following equation. It's going to be negative b over 2a, right? This is a part of the quadratic formula, so you don't have to really memorize this if you have the quadratic formula down. But yeah, let's just solve for it now because we have our corresponding values, right? We know that our b value is going to be represented by negative 14, so let's just label this as b. And then our a value is going to be positive 1, so let's label this a. So then our b value will be negative 14, but this is negative b, and so we have negative 14. There we go. And then for the bottom part, let's change to red. We know a is just going to be 1, so that should be 2 times 1 is 2. And so therefore, we will get the following. We will get, change to green, we will get 14, right, because a negative of a negative is going to be positive over 2. And so 14 over 2 is going to be 7. And so 7 will be our x coordinate of the vertex. And we know the vertex here represents the minimum of where y will reach its minimum. The smallest solution to the equation. So this is just straight up algebra, right? So let's just start this off, right? So I'm not going to rewrite the entire thing, but we have square root x minus 2 squared equals square root 3x plus 34. So the first thing we want to do here is get rid of the square root. So let's just square both sides, right? And so we'll bring this over, and so now we're left with the following equation. I won't write this in white. So we have x minus 2 squared equals 3x plus 24. And so now we know that x minus 2 squared can be rewritten as x squared minus 4x plus 4. And we can set this equivalent to 3x plus 34. And so now we just want to get everything on one side, right? Because then it's going to become a quadratic equation in which then we can just factor and solve for the zeros. So here, if we subtract 3x and subtract 34, we'll get the following. We'll get x squared. Negative 4x minus 3x will be negative 7x. And then positive 4 minus positive 4 minus 34 will give us negative 30. And the important thing here is we want to set this equal to 0. And so now we can just factor this out, right? So we have x squared minus 7x minus 30. You know the drill, find two numbers that multiply to 30, or negative 30 in our case, and add to negative 7. So here we can just write x, and we just find the factor. Let's use 10 and 3. And so we can use negative 10, x minus negative 10, and x positive 3. And that will be equal to 0. And so now we want to solve for the x values, right? So we can just set both of these equal to 0. So we have x minus 10. That was a little wonky. X minus 10 equals 0. And x plus 3 equals 0. And so we can find that x equals positive 10 and x equals negative 3. And so it wants the smallest solution to the given equation. And so we can clearly see that negative 3 is smaller than positive 10, and therefore negative 3 is going to be our answer. So the following are solutions to the given equation where a is a constant and a is greater than 30. All right, so first off, we have three possible answer choices. So a plus 1, or 29. And so what we want to do first is, well, we can just plug in these values to see if they work out, right? So these rules or solutions are really just substitutes for the value of x, right? And therefore, we can say for the first one, if we were to test it, we replace x with a. So we have a minus 29. We know a is a value greater than 30, so that's just something to keep in mind. And then on the other side, we're going to have x replaced with a. So we end up getting a minus a. And then that is going to be multiplied by x minus 29, which is just the same thing as before, a minus 29. Something interesting you'll realize here is that a minus a is equivalent to 0. And so anything we multiply here, say a minus 29, that will be equivalent to 0, right? And we know 0 is not equivalent to the left side of a minus 29. And therefore, we can rule out number 1 as an answer choice. And so anything in our answers with rule 1 in them is going to be incorrect. So A is wrong, B is wrong, and even D is wrong. And we only have one answer choice left, and therefore that is the answer of choice C. In the given system of equations, h is a constant. If the system has no solution, what is the value of h? All right, so if the system has no solution, that means the lines will never intersect. And we can see here we're dealing with linear lines. And so linear lines that never intersect are going to be parallel lines. And we know parallel lines have the same slope and different y-intercept. So in order to do that and find the corresponding values for the constant of h, what we need to do is first put these equations into slope-intercept form. So the top one right here, what we can do here is add 9y to both sides, and then we want to subtract 5 from both sides, just so we can isolate for y. So we have 18y equals 4x minus 5. And now for slope-intercept form, this will just simplify. We divide both sides by 18. So y will be equivalent to 4, 18, x minus 5 over 18. All right, so this is our equation, right? That means what we need to do is get this equation, the second equation right here, to have the exact same slope of 4 over 18, but a different y-intercept. So let's see if we can do that. So we have hy equals 2 plus 4x. So let's zoom in on this slope, right? The current slope is 4, as a value of 4. Let's just ignore the x for now. So the current value of 4 is much more different versus the slope that we want, which is 4 over 18. So how do we go from 4 to 4 over 18? Well, we can do this by just multiplying 4 by 1/18. And therefore, that will give us 4 over 18. And so how do we multiply 4 by 1 over 18th? Well, that's the same thing as dividing 4 by 18, right? And we know that in order to divide this 4x, the h value will have to represent that, right? So let's say h was 18, then 4 would be divided by 18 when you isolate for y. So I'll show you how this works. So if h was 18, then we get 18y equals 2 plus 4x, right? And so now when we isolate for the y value, divide both sides by 18, we get y equals 2 over 18 is 1/9 plus 4 over 18 x. And so now we have our two equations, right? We have this equation and this equation. We can clearly see that they have the same slope of 4 over 18, right? But they have different y-intercepts as we wanted before. So this one has a y-intercept of negative 5 over 18. This one has a positive y-intercept of 1/9. This is messy. But because of that, we know the constant h is going to be the letter D, 18. It says for an electric field passing through a flat surface perpendicular to it, the electric flux of the electric field through the surface is the product of the electric field strength and the area of the surface. So it says a certain flat surface consists of two adjacent squares, which I've drawn down here. It says in meters of the larger square is 3 times the side length in meters of the smaller square. So we have represented this by x for the smaller square and then just 3x for the side lengths of the larger square. So it says an electric field with a strength of 29 volts per meter passes uniformly through the surface which is perpendicular to the electric field. If the total electric flux of the electric field through the surface is 4,640 volts times meters, what is the electric flux in volts times meters of the electric field through just the larger square? Right, so that's a lot of information there, but essentially it boils down to electric field times area equals the flux, all right? And you can see that they've given us the electric field strength, which they say is 29 volts per meter. So 29 is going to be our electric field strength. And now the thing with the area is we don't know what the area is. But we can solve for the area because they've given us the total flux that affects both the small and large square. So the total flux is 4,640 volts times meters, right? So what we can do here is just a simple calculation to find area of the total area. So here we can just have area, and this will be 4,640 divided by 29. So the area would be 160, meters squared, all right? So there we have it. We have the total area of the adjacent squares, but we want to find just the area of the large square because if we do that, we can multiply that by the field strength in order to get the flux that it's affected by. So here's what's going to look like. So we have the total area here, and we already have variables for the side lengths, right? So in reality here, we can just set 160 equal to, let's see, we have the first square. To find the area, it's just length times width, right? So we have x times x. So we get x times x, and we add this to the other square, which is 3x times 3x. So you have 3x times 3x. And what we get here is x squared plus 9x squared. So those are like terms, right? So x squared plus 9x squared, that's just going to give us that's going to give us 10x squared. So now we have 10x squared equals 160, right? So we can divide both sides by 10. We get 16 equals x squared. And then we can just take the square root of 16 equals x squared, square root of x squared. And we're going to take the principal square root, so that's just going to be a positive 4 equals x. So we found the value of x, and that's helpful because now, let's bring this up. We can just plug in x. We can plug in a value of 4 for x for the side length. So up here we have 3x. So now we can just have 3 times 4. So we know the side length is 12. So 12 times 12. So we're finding the area of the larger square. So the total area there is 144 meters squared. So now we have the total area of this larger square, right? And so now that we have the area, we know that because of this relationship up here, it told us that the total electric flux is going to be the product of the field strength, which we already know is a constant 29 because that's volts per meter, right? Times the area of the surface, right? So what we can do here is just very simply 29 times 144. And 29 times 144 will give us a final value of 4,176 volts times meters as our final answers. In the xy plane, a circle has center C with coordinates hk. So let's just draw our diagram here. So we have this circle, not a great circle, but we can deal with it. And it has a center C, right? So let's just label this C. With coordinates hk, point A and B lie on the circle, and point A has the following coordinates. So h plus 1, k plus square root 102. So that's an interesting way of depicting point A. But since we know point A is somewhere on the circle, so let's just label like point A like here, point A. We know that what this plus 1 represents in relation to hk, and we know hk is the center, right? So this is our center, and so point A has the coordinates of h plus 1, so h determines the x-axis location. So we can just move this here. So we know this side length right here that we just drew is going to have a side length of 1. And then k is going to represent the y-axis, and that's a positive, so we're going to go up. So here, that length right there is going to be square root 102. So I'm going to see if there's a good way for me to squeeze this with square root 102. Okay, and we know this is point A, right? So now it says angle ACB is a right angle. What is the length of AB? So we actually need to label point B. We don't know where point B really could be, but let's just put it somewhere on there, right? So we say, let's say it's right here, right? Point B. Draw B in. It says ACB is a right angle, so we actually do have to account for that. So if you drew this in, boom, and a right angle would actually look like this. So what I'm going to do is erase this over here. Oops. Well, there goes our entire circle. There we go. So now I can actually draw B in. B, boom. Okay, cool. So we know that this is a right angle. This angle ACB is a right angle, as they told us. And they wanted us to find the side length of AB. So AB is going to be this side length right here. It's going to go across, right? So we need to find the side length of that, and that's the hypotenuse. So in reality, we can see here is that we have two triangles encompassing each other and making up one triangle, all right? So in order to solve this problem, we need to use the Pythagorean theorem. So first off, in this first triangle, we're going to have a triangle AC and then this random point out here. So let's just call this like X. So triangle ACX, right, is going to have side lengths of square root 102 and 1. And those are the legs, right? And we know this is a right triangle. So we need to use the Pythagorean theorem in order to find that hypotenuse length. So that Pythagorean theorem is just a squared plus b squared equals c squared, right? So we have square root 102, square root 102 squared plus 1 squared, which is just 1, equals c squared. So we end up getting 102 plus 1 equals c squared. So in reality, what we get is 103 equals c squared. So we know that if we just take the square root of both sides, c is going to equal square root 103. So we found the side length of this side now, so square root 103. And so here is something you want to take note of, right? Side length AC is going to represent the radius, right? That hypotenuse leg, just the hypotenuse in general right here, represents the radius from the center out to one of the points, because point A is on the circle. The same thing is occurring with point B. Point B lies on the circle and is also connected to C, the center. Therefore, this represents the radius, right? AC, the distance of square root 103, that's the radius. And so we can just apply that same value to side length CB. And the question wants us to find the length of AB. And so now we know the length of two of the legs, square root 103 for both sides. We can just use the Pythagorean theorem again to find the length of AB. So then we have square root 103 squared plus square root 103 squared equals c squared. So then we get 103 plus 103 is 206 equals c squared. Then we just take the square root of both sides
we can see that the answer is going to be square root 206, and so our answer choice is A. So this is a very common percent problem that you might, get on your exam. So it says the result of increasing the quantity x by 400% is 60. What is the value of x? All right. So first off, let's just write a mathematical equation to represent this scenario. So we have x, that's our starting value. We're increasing the quantity of x by 400%, right? So we're adding 400% of x to x. So we can just represent this by plus 4x. And we know our final value will be 60. And so in reality, this will just be 5x equals, it's not letting me write today, 5x equals 60. Therefore, solve for x, that's going to be 12. All right. So another way you could think about this is that if you increase the quantity by 100%, you're doubling it. So if you increase it by 200%, you're tripling it. And therefore, in reality, by increasing the quantity by 400%, you're really just multiplying the original value by 5. And so 60 divided by 5 is 12. And yeah, that's an easy way to think about it. Adam's school is a 20-minute walk or a 5-minute bus ride away from his house. The bus runs once every 30 minutes, and the number of minutes W that Adam waits for the bus varies between 0 and 30. Which of the following inequalities gives the values of W for which it would be faster for Adam to walk to school? Right, so the first thing to notice here is that for all of our inequalities, everything on the right side is a constant 20, right? So that represents that 20-minute walk that Adam has the option to take. Everything on the left side, therefore, represents that bus ride. So it's the 5 minutes of the bus ride from his house to the school, including that waiting time from between 0 to 30 minutes. So if we want the inequality that shows that it's faster for Adam to walk to school, that means that 20 minutes is going to have to be less than whatever's on the left side, because then that shows that it takes less time, right? So first off, we can eliminate two answer choices because these don't show that relationship. So the first one is A, and then the second one is C, right? These show that 20 is greater than the left side, which we don't want. And now we're down to B or D. Well, the thing with B is it shows W minus 5. In reality, this doesn't really make any sense because that 5-minute bus ride is included in the waiting time, right? So the waiting time here is W, the amount of time that Adam has to wait for the bus. And so we want to add on that 5 minutes because it takes 5 minutes to actually get on that bus from his house and actually arrive at school. And therefore, it can't be minus 5 because we're not taking away time, that's just adding time to him. And therefore, our answer is going to be choice D. Shipping service restricts the dimensions of the boxes it will ship for a certain type of service. The restriction states that for boxes shaped like a rectangular prism, which I've drawn one out here, it's a pretty good drawing actually, the sum of the perimeter of the base of the box and the height of the box cannot exceed 130 inches. The perimeter of the base is determined using the width and length of the box. If a box has a height of 60 inches and its length is 2.5 times the width, which inequality shows the allowable width x in inches of the box. All right, so first off, let's label our diagram, right? So we know the height they give us is 60 inches, so let's just write 60 out here. Oopsies. There, 60. And then they also give us the width, which is x. Well, we don't really have a value for x, so we'll just label x out here. We know the length is 2.5 times the width, so we just write this as 2.5x, right? And now what we need to do is set up our inequality. So let's use green and write out 130 because it cannot exceed 130, right? Therefore, I'm going to write up the sign like this, but it can be equal to 130. It just can't exceed 130. All right, so now we need to find what the restriction actually is for that 130 inches, right? Well, it says right here, it's the sum of the perimeter of the base of the box and the height of the box. And so the height of the box, first off, we have a value of 60. So we have 60. And it's the sum, so we're going to add this to whatever we have with the perimeter of the base of the box. So the perimeter of the base of the box is just that base, that one side, right? So that one side, we're going to have that length and that width. However, there's that other side. I'm trying to make the drawing. So this is a three-dimensional object. So you have two widths in reality, right? So you have a width on this side right here, and you have a width on the other side. And the same thing with the length, right? So you have 2.5x on one side and 2.5x on the other side. And therefore, when we write our inequality to find the perimeter of that one, side, we can just double the addition of both the length and the width. And so we can write this as 2 times 2.5x plus x. All right, so now what we want to do is just expand this out. So 2 times 2.5x will just give us 5x. And then 2 times x is going to be 2x. And so we get 7x over here. So in our equation, we're going to have 60 plus 7x. And that is going to be less than or equal to 130. And now we can just solve for x, right? Because x is going to be that width that we're trying to solve for. And so we can just subtract 60 on both sides, and we get 70 is greater or less than 7x. Divide both sides by 7, and we get x is less than or equal to 10. So we get this inequality over here, and we want to match it up to the answer choices. So let's look at our answer choices. So for A, we have x is greater than 0, but less than or equal to 10. Well, that actually lines up exactly with our equation, right? For all these inequalities, the minimum or x has to be greater than 0, which makes sense because you can't have a width of 0, right, for a box like a rectangular prism. And therefore, since this part of the inequality matches up with what we have down here, it's the same thing but flipped, our answer choice is going to be A. Ben is working this summer as a part of a crew on a farm. He earned $8 per hour for the first 10 hours he worked this week. Because of his performance, his crew leader raised his salary to $10 per hour for the rest of the week. Ken saves only 90% of his earnings from each week. What is the least number of hours he must work the rest of the week to save at least $270? So first off, let's just set up our inequality, right? So he needs to save at least $270, right? 270. And so he can save more than 270, but he needs to save at least 270. So greater than or equal to. And then his savings, it says right here, he saves only 90% of whatever he earns, right? So whatever we have with his $8 per hour or $10 per hour for X amount of hours, right? All that is going to be cut down by 90%. So we can write a 0.9 on the outside and then a parentheses for all of our values on the inside, right? So the first thing we want to account for is his initial 10 hours that he worked. So he worked that initial 10 hours at a rate of $8 per hour, right? And therefore, since he worked 10 hours at $8 per hour, he made $80. So we just write a flat $80 right there. But then his performance increased, right? And therefore his salary also increased. It says his crew raised his salary to $10 per hour. We don't know how many hours he's going to work at $10 an hour, but we know that he must work a certain amount of hours to make at least $270. To save at least $270. Therefore, we can write this as plus 10, because that's the flat rate. And then we can just write x as the number of hours he works. And x, in our case, in this inequality, will represent the least number of hours he must work to save at least $270. All right, so now we just want to simplify this inequality, right? So 0.9 times 80 is going to give us a value of 72. 0.9 times 10x is going to be plus 9x. Set this equal to greater than or equal to 270. Okay. And so we want to subtract 72 from both sides because we're isolating for x. And so we get 198 is less than or equal to 9x. Divide both sides by 9 and we get a value of 22 is less than or equal to x. All right, so what does this represent? Well, this means that in order to save at least $270, they will have to work, or who's there? Ken will have to work at least 22 hours, right? But this also means that, if he works greater than 22 hours, he'll save more than $270. But we just want to find the number of hours that it'll take him to save at least 270 hours, working the least number of hours, right? And the least number of hours in our case is right here, 22 hours, because that's the minimum that he has to work. And therefore, our answer choice is going to be C. Intersecting lines R, S, and T are shown below. what is the value of x? Well, they give us two angle measures, right? We have this 106 degrees out here and 23 degrees out here. So the first thing you want to take note of is supplementary angles, right? So because this 106 degree angle is on this line S, this missing angle here, which actually represents this triangle, that is going to mean that 180 degrees minus 106 degrees is going to be equal to this missing angle. And so we can pretty easily just do 180 minus 106, and that will give us a value of 74. So we know this angle right here is going to be 74 degrees. And now we have two angle measures of a triangle, and so we can find the missing angle measure, right? So this angle right here at the bottom. And so we just do 180 minus 23 minus 74, and we get a value of 83. So because this side right here, or this angle, is 83 degrees, that means we can also use supplementary angles again to find the value of x. Now why? Because we have two angles lying on the line R, right? So any two angles on a line will be equivalent to 180 degrees. And so here we're going to just do 180 minus 83 and get our value of x, which is going to be 97 degrees. And yeah, that's how you see O is the center of the circle above. And the measure of angle OAB is 30 degrees. All right, so that's going to be 30 degrees right there. Boom. If the length of line segment OC is 18, so this is 18, what is the length of arc AB? So I think this is the minor arc of AB right here. Well, the first thing to note here is that OC represents the radius, right? Or the radius. So because OC is the radius, right? Because it goes from one point on the circle to the center, we know that the radius has a value of 18. Now the same thing happens from B to O, and as well as A to O. And therefore we know that the side length of AO is going to be 18. So let me write. Is 18, and the side length of BO is also 18. Now here's what's interesting, right? Because these two side lengths are equal, right? We know they're opposite angles. The angles opposite to them are also going to be the same, right? And so if this right here, a 30-degree angle is opposite of 18, we know that this angle right here is also going to be 30 degrees. And it's kind of funny because now we have a isosceles triangle, right? So it works out in the end. So this angle right here we can conclude is 120 degrees. Boom. All right, so now how do we actually solve for the length of AB, right? Well, here's the thing. We know that AOB, that angle, the 120 degrees right here, that is the inscribed angle of the arc of AB. So technically speaking, the length of the arc is 120 degrees. However, we want to express it in, first off, radians, and also it'll be based on the circumference of the circle, right? So first off, let's just find the circumference of the circle. So the circumference of a circle is equivalent to 2 pi times radians. And therefore our radians, the radius, not the radians. So the radius is equivalent to 18, right? So we can just do 2 times 18 is 36 pi. And so that is our circumference, all right? And so in order to calculate the length of the arc, what we can just do is first just find the ratio to scale it up. So we have 120 degrees over 360. So that in reality in itself is just 1/3, right? So what we want to do is just take 1/3 of that circumference. And so 1/3 of that circumference, which we know the circumference is 36 pi. So 36 pi, 36 pi, let's just divide this by 3. Because we know that this angle represents 1/3 of it. And so we can just do 36 over 3, which is 12, and keep the pi, so we don't have to simplify it completely. And so our final answer here is going to be an answer of 12 pi, and let's see, it does match up with answer choice B, and therefore that is our answer. So it says a rectangle is inscribed in a circle such that the vertex of the rectangle lies on the circumference of the circle. All right, first let's just draw this out, right? So the first thing you have to do with these geometry problems is interpret them. And, there's all this weird wording there, but as long as you just take it step by step, word by word, you'll be fine. So the rectangle is inscribed inside of a circle. So I'm going to draw a circle and then draw a rectangle. So the rectangle is drawn such that the vertex, or each corner of the rectangle, lies on the circumference of the circle. So what it's going to look like is one corner goes there, boom, and then the corners of that rectangle are going to be on the circumference or the outside of that circle. So there's our drawing. It says the diagonal of the rectangle is twice the length of the shortest side of the rectangle. All right, let's draw that in. So the diagonal, which is going to look like this, just going across from one corner to the other, is going to be twice the length of the shortest side of the rectangle. So this right here is our shortest side, and so let's just label that x. Let's call that x. And it's twice the length, so we can call this 2x. Therefore, that is twice the length. The area of the rectangle is 1089 times square root 3 square units. What is the length in units of the diameter of the circle? All right, so the diameter of the circle, right, is just its radius times 2, because that's just from one end of the circumference to the other end of the circle. And you can see that the diagonal actually, satisfies that condition. And therefore, the diagonal of this rectangle is that diameter of the circle. But how do we actually find our side lengths? Well, you have to use this thing on the side. That's the reference table that the digital SAT provides, right? This is provided to you. You have to focus up top on the special right triangles, all right? So if you're not thinking of special right triangles, you might be in a bottomless pit trying to solve this problem, because special right triangles is the easiest and fastest way to do this. So you can see here, for one of our special right triangles, the 30, 60, 90, we have side lengths 2x, x, and x times square root 3. That matches up with this triangle over here, right? We have side lengths x for one of the legs, the hypotenuse is 2x, and therefore we can infer that the other side is going to be x times square root 3. So x times square root 3 is going to be our final side for that part of the rectangle. And we know length times width equals the area of a rectangle, and we have the width right here and the length right here. And so we just have to multiply those together. So x times x square root 3 is going to give us the area that they provided. So 1089 multiplied by square root 3 square units. And all we have to do now is solve for x. So you can plug this right into Desmos, and it'll give you an answer of x equals 33. And so now that we know what x is, all we have to do is plug it in here, right? So x is 33, so we know one of the side lengths is 33, but that diameter is that diagonal of the rectangle. And the diagonal of the rectangle is 2x. And so 2 times 33 gives us 66 as our final answer. Function f is defined by the standard form of a quadratic. A, b, c are constants. When it's graph, it passes through these points. So these 2.70 and negative 30, these are the x-intercepts. It says if a is an integer greater than 1, which of the following could be? So could means that there are multiple possible values, but just based on our selections here with our choices, which one could be a value of a plus b? So first off, let's just write what we know. So we know f of x is our function, and a is an integer greater than 1, except we don't know what it is, right? So let's just write a to represent it. However, what we do know are the roots, and that is 70 and negative 30. So when you have these coordinate points as solutions, you can rewrite them in their factored form. So 70 can be rewritten as x minus 7, because when you set this equal to 0, you solve and get positive 7. And negative 30 can be rewritten as x plus 3. Right, that's interesting. But now to actually expand this out and actually get a value for b, what you might realize here is that we need to actually have a value for a, right? So it says a is an integer greater than 1. Well, what's an integer that's right above 1? Well, 2. So let's just have a value of 2 for a. So then we have 2 times x minus 7, and then x plus 3. So now we can just expand this out. So let's just do this part first. So we have x squared, and then we'll get negative 4x, and then minus 21. So then we have to apply the 2 right here to the outside. So then we have to multiply this entire thing by 2. So then we get 2x squared minus 8x minus 42. Right, there we go. So it says, which of the following could be a value of a plus b? Well, which ones are a value, which is right here, a value, and our b value, right here. So our a value is positive 2, and our b value is negative 8. And if we add those together, positive 2 plus negative 8 is just 2 minus 8. That's going to give us the answer choice of A. A circle in the xy plane has its center at coordinates -4, -6. Line K is tangent to the circle at points -7, -7. What is the slope of line K? So this is an interesting problem because when you talk about like geometry on the SAT, you don't really get too much into the obscure concepts. So we have tangent lines on a circle. This one thankfully is quite simple and straightforward, so I'll show you how it's done. So if we draw like the coordinate plane here, and we know that the circle has its center at these coordinates, -4, -6. So it's like going to be somewhere, I don't know, like right here. And we don't actually know the radius of the circle. We probably could calculate it using these points and finding the distance and stuff, but that's not really relevant for our problem, and you'll see why. So line K is tangent to the circle at the point -7, -7. And so -7, -7 is out here somewhere. And so, I mean, the radius is going to be like somewhere like this. So we have that. That's a really lopsided, ugly looking circle and probably not drawn to scale or accurately. This is just a visual representation. And so line K, I'm going to draw in black here, is tangent to the circle at this one point right here, which means the tangent line is going to go through like this, because tangent lines I'm going to hit at only one point on that circle. So it'll go infinitely on both sides. And so we want to know the slope of this line. So the only way to determine the slope of this line is to use the information we already know. So we know 2 coordinate points, right? And these 2 coordinate points, only one of them are actually on line K. And so what we need to do here is actually find the slope of the perpendicular line to line K. So if we draw another line through the green line, that's a bad diagram. So we draw it through like this. Just pretend that's a straight line. You can see that the green line is going to make a perpendicular angle with line K. And so those are perpendicular lines. And perpendicular lines have opposite reciprocal slopes. And therefore, what we need to do is actually just find the slope of line K. Find the slope of the green line here, and then we can find the slope of line K. So the slope of the green line, let's draw over here, is going to be based on these 2 coordinate points. So the equation is going to be y2 minus y1 over x2 minus x1. And so here, let's just look for the change in y. So the change in y, we're going to be going from -7, -7 to -4, -6. And so the change in y, which is -7 to -6, that's a change of +1. So +1 on top. Now the change in x, so we're going from -7 to -4. That's an increase of +3. And so, right, +3. And so we know the slope of this line is 1/3, and which makes sense because if you look at the diagram, it is positive. It's going to be positively linear, and therefore a positive slope as 1/3 makes sense. So then what is the slope of line K? Well, we just need to take the opposite reciprocal, and the opposite reciprocal here is going to be -3. And therefore our answer choice is going to be A. Function h is defined by h of k equals ax plus b, where a and b are positive constants. All right, so let's just keep that in mind. The graph of y equals h of x in the xy plane passes through 0, 10, and -2, 3, 25 over 36. What is the value of a plus b? All right, so when they give you these 2 coordinate points and a general equation like we have here, ax plus b, let's just start plugging in the numbers and see what we can make of it, right? So h of x is just our output or our y value, and we can see here in the first one, our y value or output will be 10. So we have 10 equals, we don't know what a and b are, but we can figure it out from these values. So here it says that with the input of 0, so x equals 0, we're going to get an output of 10. Well, let's see. So a to the power of 0 is going to give us 1. So here we have 1. So 10 equals 1. So this is plus b. And so what added to 1 gives us 10? Well, that is going to give us a value of 9. So we still do not know what the value of a is, but we know whatever a is to the power of 0 is going to be 1. But we have now just found out the value of b, right? And it makes sense because b is a positive constant. Now what we want to do is tackle the second part. So the second part here is negative 2 comma 325 over 36. So let's see what we can do here now that we know what the b value is. So we know the output is going to be 325 over 36. So 325 over 36. And we want to set this equivalent to just our general form ax. So a, we don't know what that is. X here, in our case, right here it says it's negative 2. So negative 2. And we already found the b value from our previous journey up there. So that's going to be plus 9. And so now what we want to do is just solve for a, right? So we can subtract 9 on both sides. And this is actually interesting because 325 over 36, 9 times 36 is going to give us 324. And so when we subtract 9 on both sides, that's in reality is just subtracting 324 divided by 36. And this will be set equal to a to the power of negative 2. And so if we want to solve for a here, let's simplify the left side. That is going to be 1 over 36 equals a to the power of negative 2. And you can plug this into Desmos and solve it, but here there's just exponent properties. So a to the negative 2, that is the same thing here as just 1 over a to the power of 2. And so because we have 1 over 36 equals 1 over a to the power of 2, what we can do here is just disregard everything on top because we can take the reciprocal of both sides. So this in reality really is just 36 equivalent to a squared. So now what we can do is just solve for a by taking the square root of both sides. And on the SAT, when you take the square root, when you manually take the square root of something, you are taking the principal square root, and therefore you only want the positive solution. And so instead of negative 6 and 6, it's just going to be positive 6 as our final answer. So positive 6 here is our answer for a, but the question is asking for the product of a and b. So we know here that b is a value of positive 9, and a is a value of positive 6. So 9 times 6 is going to give us a value of 54, and therefore C is going to be our final answer. All right, so the next problem says a circle in the xy plane has a center at those coordinates of negative 5, 2, and has a radius of 9. The equation of the circle is x squared plus y squared plus ax plus by plus c equals 0, where a, b, and c are constants. What is the value of c? All right, so the thing here is we've drawn out what we have, the standard form for a circle, right? And so what we have are these centered coordinates, and we know the centered coordinates correspond with h and k respectively in this equation. And we also know the radius, so we can just plug these numbers in. And so here we'll have x, and because we have a negative 5, and the standard form here is a negative, in reality, h here, h is negative 5, right? So if you take a negative of a negative, that's in reality just positive. So x plus 5 here is going to be squared plus y minus k. K here is just positive 2 squared equals the radius squared. The radius we know is 9, so 9 squared is 81. And so now what you'll realize is if we just expand this out, right? We have two parts here that we can expand out. If we expand this out, it'll become eerily similar to the form we have here because we're going to break it up into the x squared, the ax, the y squared, and the y parts. And so here we have x plus 5 squared, which is the same thing as just x squared plus 10x plus 25. I'm going to switch colors for the y minus 2 part. That is going to be plus y squared minus 4x plus positive 4 equals 81. And so what we're interested in seeing here is the c value, right? The c value is the constant, and it doesn't have the x or x squared in front of it. And so because of that, we can actually determine what it is, because on this side you can see it's 0, but on our side here is value of 81. So what we need to do is subtract 81 on both sides. Boom, boom, boom. And then once we subtract 81 on both sides, we just want to combine like terms, right? We have a positive 25 here, a positive 4 here, and then a negative 81 here. So here we just have 29 minus 81. And 29 minus 81 will give us a value of negative 54. And therefore we can determine that the value of c here is just going to be negative 52. For the function f, for each increase in the value of x by c, where c is a positive constant, the value of f of x increases by a factor of 27, which of the following equivalent forms of the function displays 1 over c as a coefficient of x. So this is really weird wording, but essentially what they're trying to get at is they're looking at 1 over c in relation to the coefficient of x. So what they want is for x and c to be equal, but still increase f of x by a factor of 27. So what this means is, let's say we're looking at option A, 1/2, the c, which is under the 1, is a value of 2. And so what they want is they want x to be also equivalent to 2, but then scale the entire thing up by 27. So the first thing we want to note is, what is the starting value? The starting value is 48. Now why? Because when x is 0, what happens is we get anything to the power of 0 equals 1. So 3 to the power of 0 is 1. 3 to the power of 3, 9 to the power of 0 is 1. So everything times 1, so 48 times 1 is going to be 48. So that's our starting value, all right? So you want to scale up 48 by a factor of 27. So we'll just get 48 times 27 equals 1,296, all right? So now that we have this equation, what we can do is actually just set it equal to our standard form of all these equations. So we can do 1,296 is equivalent to 48 because they all have 48 in them. And let's put this equal to 3 to the power of x. So 3 to the power of something. And so now we can just solve for x. In our case, x here is going to be equal to 3. So what we know is, for these equations, for them to be the right answer, what we need is for 48 to be multiplied by a value of 9. Now, not only does it have to meet that criteria, but the x, as before, with that relation to c also has to hold true. So let's just go through it and see which one works. So for a, we have 1/2 times x. X has to be 2. So 1/2 times 2 would be 1. And therefore, we get 3 to the power of 1. That's not 9, right? We're looking for 9 because we have 48 times 3 to the power of x, and we know x is 3. Let's look at b. So it's not a. b is 48 times 3 to the power of 3, 1/6 times x. So x here has to be 6 because of that coefficient of c. And therefore, 6 times 1/6 is going to be 1, right? So then we have 3 to the power of 3 to the power of 1. 3 to the power of 3 is going to give us 27, right? So 27 times 48 is indeed this factor. And so B is going to be our answer for that question. All right, moving on to the next question. Ignore whatever's on the right side. This is for the very next problem. So this one says, for each real number r, which of the following points lies on the graph for each equation in the xy plane for the given system? So the first thing to note here is that these are the exact same lines, right? If I were to scale this up by, say, 5, I would have 5 times 2x is 10x, 5 times 3y is 15y, 5 times 7 is positive 35. And therefore, if I were to graph it, they would be the exact same line. It would be on top of each other. And therefore, all we have to do with this problem is find a value of r, which can be any real number, and just have these coordinate points satisfy any one of these equations. So to do so, let's just pick a random number for r. Let's make it 5 here to make it easy. So 5 over 5 is 1. 1 plus 7 is going to be 8. So that's our x coordinate. And then we have 5 over 5, that's negative 1, plus 35 is 34. And so now we can just plug these values in and see if we get the right answer. So we have 2 times x, and we know x they give us is 8. So you have 16 plus 3 times 34. Well, this is already not going good because 3 times 34, that is a very large positive number. That is not even close to being equivalent to 7. That cannot be the right answer. So the answer is not A. Let's move on to the next one, B. So B, let's just plug in 5 for r again because we've been using r as 5. So 3 times 5 is 15. And then 15 over 2, negative 15 over 2. So negative 15 over 2. It looks like we have to add this to 7 over 2. So then we get actually, what is this? Negative 8 over 2, which gives us negative 4. and -4, and then that's our x coordinate, and then our y coordinate is just going to be r, right? R we said is 5. And therefore, if we plug this in, well, we get the satisfied equation. So we have 2 times x. So x is, oops, this. So x is going to be -4 plus 3. Our y value is 5. And I think this is going to be looking good because we have 2 times -4 is -8. Yep, plus +15 is indeed equal to 7. And therefore, our answer for that question is going to be B. All right, so moving on to the questions for practice test 2. This one says, in the xy plane, the graph of the given equation is a circle, so this equation. The length of the radius of the circle is np, where n and p are positive constants. What is the value of n? All right, guys, so this is a very simple problem if you have access to Desmos, right? So instead of completing the square and all that stuff, all you have to do is really just plug into Desmos. So if we move over here, you can see all I did here is I plugged this equation into Desmos, added a slider for the constant p. I just set p equal to 1, but you can have it as any positive constant. And you can see here that the center is -7,4, and you can pretty easily tell the radius from this depiction, right? So you can see the radius here is going to be 3 units. And so if we move back to our question, it said that the length of the radius of the circle is n times p. So n times p is going to be equivalent to the radius, which we said over here was going to be 3. And what do we set p equal to? We set p equal to +1, right? So if p is +1, then we know 1 times n equals 3. So n must be 3, and therefore 3 is our answer. All right, moving on to question 17 for practice test number 2. This one says, which of the following represents the x-intercept of the graph of y equals f of x plus 9 in the xy plane where d is a constant? All right, guys, so this is the same deal. All you have to do is know how to use Desmos, right? So the first thing I did over here is you can see I just plugged this equation, the entire thing right into Desmos, and it plugged it right here, right? We get the x-intercept, but that's not what we want to find. You have to interpret the question. It says, which of the following represents the x-intercept of this f of x plus 9? So there's a transformation. So all we have to do here is, after setting the slider for d, which I just set as 1, so it didn't really impact the equation, all you have to do is just write f of x plus 9, right? That's a transformation they described and applied it right here. This red line right here is going to be that x-intercept. And so you can click on it and it tells you the exact x-intercept. And so now we know that's going to be -1.2667. So go back to your answer choices, and we know we set d equal to 1. So all we have to do here is pretty much just guess and check, right? So we plug in 1 for d in all of our choices, and we see we actually lucky out here. The first choice here is going to be -126 times d is 1 minus 26 over 120 will give us that value of -1.2667, which lines up with our x-intercept over here. And therefore, we can pretty confidently say that our answer choice. All right, guys, so we're going to be moving on to practice test number 3, the final 2 questions. So this one right here is actually the only geometry problem. It's actually a pretty interesting one. So it says, in the figure shown, side AD has a value of 121 over 3, and side AB has a value of 11 times square root 130. Oops. 130 over 3. All right. What is the length of DC? So we're trying to find the length of DC over here. All right, so the first thing I want to do is we can just use Pythagorean theorem, right? So we have the c squared value over here. We have one of the side lengths, and so we can find the value of the other leg. And so over here, you'll see I've just set up the Pythagorean theorem equation and rearranged it, and we can see that we get a value of 11. And therefore, we have BD is going to have a value of 11. All right, guys, so now what we need to realize is that there is going to be a altitude drawn into this right triangle, right? Right triangle ABC. And therefore, when the altitude is drawn, it creates 2 similar triangles, all right? And then there's also this thing called the altitude theorem, which basically states that when you have a right triangle, the hypotenuse can be broken up into line segments, and those line segments can be related by a common side, which in our case, the common side is BD because it's been present in both triangles. And we can use that in order to scale up another side to find a missing side length, all right? So I'll show you how it works right here. So the theorem basically states that if you have side 1 over that common side, that is going to be equivalent to the common side over side 2. In our case, side 1, and also it's important to note that these sides are the sides that make up the length, the legs, sorry. So it does not include the hypotenuse, right? So what this looks like here is, if we bring this down, we have side 1, which in our case is going to be side length AD, right? Because that's not the common side, and that's the only remaining leg. We can't use the hypotenuse. So you have 121 over 3. This is not working. 121 over 3 over, and the common side is going to be 11. So just put 11 equals the common side, which is 11, and then the missing side, which is going to be side 2. So that missing side will give us the value of DC, right? You can actually see right here, I've just used Desmos, right? So I put this expression in to find x, and you can see x aligns with 3. And therefore, we can determine that the side length of DC is going to have a value of 3. All right, so let's move on to the final problem here. So question 15. So it says, in the given equation, P is a positive constant. The sum of the solutions to the equation is 20 over 3. What is the value of P? All right, so this is actually a really interesting question that you have to be able to synthesize using Desmos, right? Desmos is your best friend, and it is pretty much like a cheat code. So I'll show you how it works. So the first thing I did here recognize, without even going to Desmos right here, is that 5x squared minus 45. The solution for this is x equals negative 3 and x equals positive 3. If we're interested in knowing the sum, right, we know that negative 3 and positive 3 are just opposites of each other. And if we did negative 3 plus 3, we get 0. So no matter what, that sum is going to be 0, right? So because the sum here is 0, we're adding 0 no matter what. That is actually irrelevant when we graph it. And so what we did here is just graph the rest of the equation, right? We have 2x squared minus 16x, yada, yada, yada. And so we have a value of P that's a positive constant. And so I just set a random value for P. You can see here I said equal to 2. And what I did is I found the x-intercepts. Now these x-intercepts, right, this one right here, and this one right here, these are the x-intercepts of 2x squared minus 16x plus 6p. Now how do I know that? Well, because I know 3x plus p, right? No matter what p is, p has to be a positive constant. And so because p is a positive constant, its x-intercepts are always negative. So here's our example. Let's say like 3x plus, I don't know, like 2. Yeah. So then when I isolate for x, I'm going to get 2 over 3. Negative. Boom. Equals x. And therefore, I know this thing right here, whatever that is, that's always going to be negative, and that is going to be the x-intercept of 3x plus p. And so what I did here is I added the x-intercepts, right? Because I'm trying to find the sum. So I add the x-intercepts of 2x squared minus 16x plus 6p. And I get a value of 8. That's very interesting. So I do this again with a different value of p. And I do this again, and you can see the two x-intercepts here add to a value of 8. All right? And so what happens is the only one that's changing when I change the value of p is going to be 3x plus p, right? So this one right here is going to be changing. And therefore, I can actually set this equal to 20 over 3, right? You have 20 over 3 is our sum. And so if I already have a sum of positive 8 over here, as you can see, this adds to positive 8. And therefore, we can just subtract it away, positive 8, subtract that away from 20 over 3, and we see that our difference has... Alright, so unfortunately, my recording cut out because I have a 15-minute time limit. But anyways, so we know x has to be equivalent to negative 1.333, right? And so that is the other x-intercept value, because we know the sum of 2x squared minus 16x plus 6p, no matter what p is, that sum of those x-intercepts is going to be positive 8. And we know that the limit, or the sum right here, has to be 20 over 3. And so because we got x equals negative 1.333, now we have to observe that 3x plus p, right? So the value you want to get right here is negative 1/3. And so if you look at 3x plus p, like we said before, no matter what p is, because it is a positive constant, this x-intercept is going to be negative. So we just have to have a value of p here that will give us a value of x that is -1/3, right? And that's pretty simple here, because if we just set 3x plus 4 equals 0, we can see here that when we isolate for x, we'll just get -4, because subtract -4 on both sides, and then divide both sides by 3, and we get x equals -4/3, which is the same thing as -1/3. And so our answer for this problem is, because we set p equal to +4, and that doesn't affect the x-intercepts of 2x squared minus 16x, I think you get the idea. So we have +4 over there, and therefore +4 is our value of p. All right, so this last question I picked out because it's sort of non-traditional, right? It's not something you're going to see often, but I think it's a really interesting problem. So it says, what is the area in square units of the triangle formed by connecting the 3 points shown? So, I mean, we have 3 points and we want to know what the area is. So let's just connect these 3 points so we can see that it's going to make a triangle. So let's just connect these points. And the thing with this is, you have to realize is, we're not going to be calculating like the distance between these points and then using like base times height or whatever. So what we need to do here is actually use a strategy that is common on the geometry region. So for those of you who don't know what the regions are, if you live in New York, you have like state assessments, whatever. So one of the popular problems is like you got to find the area of a triangle and stuff. And how you would do that is just enclose the shape within another shape that is easier to calculate. So in our case, we want to use a rectangle, right? So we draw this out, okay, enclose this entire shape within rectangle. So there we go. So we can just find the dimensions of the rectangle, and you can see that the rectangle here has a let's see, what is this, -3, so 7 units on this side, and then on the top it is 8 units. So here we have 7 times 8, and so we can see that at most, obviously, it's going to have an area of 56. So what we're going to do now is find the area of each of these individual triangles on the outside using base times height divided by 2. And therefore, once we find those areas, subtract it away from 56 and we'll find whatever we're left with in the middle. So let's start off with this top triangle. So we have 1 times, this looks like, what is that, 8. So 8 divided by 2. So we have 4. So this triangle right here is 4. And let's try this one over here. So this one is 7 down, and it is, looks like 7 across. So 7 times 7, that's 49 divided by 2 will give us, what is that, 24.5. And then our final triangle on this side, let's see, it's going to have a height of, looks like 6, so 6, and then a width of 1. So then 6 over 2 will give us the area of 3. So these are the different areas of the parts, or the external parts, that we want to subtract away from 56. So 56 subtract 4 is 52. 52 subtract by 3 is going to give us 49. Oops. 49. And then 49 subtract 24.5 will give us a final answer of 24.5. And therefore, our answer for the area in square units of the triangle is going to give us an answer of 24.5.